In this video, we're going to be finding angles from the unit circle based on a particular trig value. In the previous video, we were given an angle and then found the trig value from that. Now we're going the other direction. I think it's definitely the harder of the two directions. Also, you want to keep in mind whether they're asking for an answer in radian or degrees. You'll see this first example. It says find all theta in the interval 0 to 2 pi. 2 pi is radian. And then in the next example, it says from 0 to 360 degrees. So be sure that you're paying attention to that as you're answering these questions. So we want to find all angles from 0 to 2 pi, so basically one trip around the unit circle, such that tangent of theta is equal to negative square root of 3 over 2. Well, there's a couple of thoughts that I have when I start a problem like this. The first thing I notice is that the tangent value is negative. So I want to figure out, well, where does that happen? Tangent is y over x. So the tangent value is negative when one of them is positive and one of them is negative. So in which quadrants is only one x or y positive and the other one's negative? Well, that happens in two quadrants. It happens in quadrant 2 and it happens in quadrant 4. So I'm going to get two answers here. One in quadrant 2, and then another one in quadrant 4. The second thing I think of is I see that square root of 3. And I want to think to my special right triangles, which one of them ever did I see a square root of 3? And that happens in the 30, 60, 90 special right triangle. The long side on the unit circle is square root of 3 over 2. And on the general 30, 60, 90 triangle, the long side was x times the square root of 3. So that's the only time we saw square root of 3. So that tells me, all right, it's got to be the 30, 60, 90 triangle. The values of our sides in a 30, 60, 90 triangle are square root of 3 over 2 and a half. Now I have to figure out what combination tangent is y divided by x. So I need to decide, is y square root of 3 over 2 and x is a half, or is x square 1 half and y is square root of 3 over 2? And I just play with it and see. So, all right, if I do square root of 3 over 2 divided by 1 half, that's the same as square root of 3 over 2 times 2 over 1, cancel, cancel, square root of 3. So, okay, that tells me that the square root of 3 over 2 goes to the y side, and the 1 half goes to the x side. And I'm also thinking square root of 3 over 2 is the long side, x is the short side. So now I know what kind of triangle I'm going to have in those two quadrants, and I'm going to draw it in. All right, so in quadrant 2, x is the short side, y is the long side, triangle. Well, I know big angles are across from big sides, so this has to be a 60-degree reference angle. And once you've decided the reference angle in one of the quadrants, it's going to be the exact same reference angle in the other quadrant. X is the short side, y is the long side. Our reference angle's across from the long side, so this has to be a 60. And now we just need the actual angle, and they want it in radian. So our actual angle here, that's going to be 90 plus 30, this is 120. And our actual angle down here, and it's going to be 60 less than 360. So this one's 300. And now we just need to convert them to radian. So 120 degrees, we'll multiply that by pi over 180. These both simplify by 60. Our first answer is 2 pi over 3. That's our quadrant 2 answer. And then our next one, we'll take this 300 degrees and convert it. (300) and 180 are both divisible by 60. 60 goes in 5 times, goes in 3 times. We get our second answer here of 5 pi over 3. Let's try another. We want to find all theta between 0 and 360 degrees such that, let's just say sine of theta equals 1/2. I basically go through the same kind of thought process. The first thing I do is think about, well, that sine value is positive. Sine, which is our y value, is positive in quadrants 1 and 2. So I know that's where my triangles are going to be. I'm going to have 2 of them. Then I look at that 1/2 and say, okay, that's going to be the short side of a 30, 60, 90 triangle. And sine is the y, so y is the short side of a 30, 60, 90 triangle. That means that x would be the long side, y is going to be the short side, and small angles are across from small sides. That tells me this has to be a 30-degree reference angle. And then I'm going to have the exact same one in quadrant 2. Same 30-degree reference angle. And now we just need the actual angles. We're looking for degrees this time. So first one, theta equals 30 degrees. And then our actual angle over here, we're 30 degrees shy of 180. So theta equals 115 degrees. Next, we want to find all theta from 0 to 360 degrees such that cotangent is equal to -1. I start by identifying which quadrants I'm going to be in. Cotangent is x over y, and it's saying that x divided by y produces a negative number. So that means that one of them has to be positive and one of them has to be negative. That happens in quadrants 2 and 4. If the x value divided by the y value ends up being 1, right? I'm not talking about the negative now because the negative decided my quadrant. So now I'm just looking at the number part. So if I take x and divide it by y and I get 1, that means that x and y have to be the same number. Because that's the only way you get 1 is by dividing a number by itself. And if I think about my 2 special right triangles, in a 30, 60, 90 triangle, the sides are different. One's a half, one's square root of 3 over 2. But in a 45, 45, 90 triangle, the 2 sides are the same. They're both square root of 2 over 2. So I know that I'm going to have triangles in quadrants 2 and 4 with a 45-degree reference angle. Those are our triangles. Now we just need the actual values, like the actual angle measurements. Here we are 45 degrees shy of 180. So there theta is going to be 135 degrees. Here we are 45 degrees shy of 360 degrees. So our second value for theta is going to be 315 degrees. In our next example, we want to find all theta, this time in radian, right, from 0 to 2 pi, such that cosine is equal to 0. Well, that 0 jumps out at me because it's not positive or negative. So I can't identify a quadrant where cosine is not positive or negative. That kind of red flags us that this is going to be on one of the axes. Cosine is our x value. So we want to know, where is the x value 0? Well, for the x value to be 0, that means that we don't go side to side at all from the origin. So that has to be happening up here and down here. 2 spots. And then we need the corresponding radian. Well, this is 90 degrees and 270 degrees. If we think about it in radian, up there at the top, 90 degrees is equal to pi over 2. And 270 degrees, that's equal to 3 pi over 2. Over time, you're going to get much better with the radian and kind of memorize their positions, at least on the axes. For now, we can still take the time to multiply by pi over 180 and simplify from there. Finding trig values off the unit circle is very important. And then this here, finding angles given a specific trig value, is going to become very important to us when we solve trigonometric equations later in the course. So I can't stress it enough. Practice, practice, practice this.